Welcome. The Passive Sampling Technology Update team is proud to present an overview of the semi-permeable membrane device. This quick video will provide a high-level overview of the device, as well as instructions on how to use, deploy, and retrieve the device. For more information on this and other passive sampling technologies, please visit the Passive Sampling Update Guidance document. The Semi-Permeable Membrane Device, or SPMD, is an accumulation-type passive sampler that accumulates chemical mass over time while deployed. The SPMD primarily collects samples in groundwater, surface water, pore water, and soil gas. The device can also be deployed to collect ambient air samples both indoors and outdoors. The SPMD uses the Performance Reference Compound, or PRC approach to account for site-specific environmental factors such as water flow, temperature, and buildup of biofilm. These factors can affect the sampling rates of the technology. The calculated amount of PRC lost during deployment is used to adjust the laboratory sampling rates at each sampling location. The SPMD is designed to sample hydrophobic organic chemicals in surface water. The semi-permeable membrane mimics the accumulation of certain chemicals into the fatty tissues of organisms. SPMDs have also been adapted to sample halogenated organic compounds in groundwater monitoring wells and can determine freely dissolved or bioavailable concentrations of certain volatile organic compounds, polycyclic aromatic hydrocarbons, and polychlorinated biphenyls with log octanol water partition coefficients or log KOW greater than 3. The main features of the SPMD are the low-density polyethylene or LDP membrane, which contains a thin film of the triglyceride triolein, which accumulates target chemicals, the carrier assembly that houses the LDP membrane, and a protective canister, normally constructed out of stainless steel. The high-purity lipid, typically triolein, serves as a representation of the fatty tissues of aquatic organisms. It resides in a thin-walled, non-porous, lay-flat, low-density polyethylene membrane tube, which is loaded into the carrier rack within the protective canister. The tube allows the nonpolar chemicals to pass through to the lipid where the chemicals are concentrated. Larger molecules and materials such as particulate matter and microorganisms do not pass through the tube. The SPMD comes shipped from the commercial vendor as intact samplers, with the triolein film sealed in the LDP tube and the requested performance reference compound, or PRC, are added by the vendor. The type of PRC is dependent on the chemicals of interest for the project. There are various deployment canisters and sizes commercially available, including small canisters, large canisters, which can hold between 2 and 5 LDP tubes, and canisters that can be deployed to groundwater monitoring wells, and disposable canisters. The technology is customizable and can be adapted into user-defined samplers to meet the needs of individual projects. In this photo, you can see the carrier and LDP tube inside the stainless steel protective canister before deployment. Custom-made protective canisters can be used as long as those materials do not leach out chemicals of interest to the study. Site conditions and target media will impact the type of equipment needed to deploy the device. Typically, you will need deployment hardware such as cable and clamps, floats, tie-down anchors, and the tools required for SPMD assembly. When deploying the SPMD, it should be secured at the desired location in the water column. This can be achieved using a few different methods, depending on the site and target media, such as tying the device to a fixed point on the shore, hanging the device in open water, or suspending at the bottom with anchors and floats. Important things to consider when deploying the device. The sampler must remain submerged for the entire deployment period, but not buried in the sediment to achieve data representative of the target media. If the device is exposed to air, there could be a potential loss of chemicals with higher volatility from the SPMD and accumulation of chemicals from the air, resulting in measurements of non-target media. It is important to keep the device shaded to prevent the photodegradation of some light-sensitive chemicals, such as PAHs. Deployment time can range from days to months depending on the targeted chemicals of concern. The sampler in this photo was deployed in a river for 2 to 3 months, and you can see the buildup of biofilm that occurred. Once the deployment period has been achieved, the device is removed from the water and placed on ice in airtight shipping containers to be returned to the laboratory. Chemicals captured by the sampling device can be extracted in the lab using a two-step dialysis method. Dialysis is a common laboratory technique that uses diffusion to separate, isolate, or otherwise partition molecules of the target analytes. First, the LDP membrane material is subjected to superficial cleaning to remove any particulate matter and biofilm. Then it is immersed in a buffer solution such as hexane. Following dialysis, additional cleanup and fractionation of the samples depends on the target analytes, but typically involves size exclusion chromatography and other sorbent-based chromatographic methods. Some of the advantages of the SPMD include: the technology uses accumulation to calculate a time-weighted average concentration within the medium sampled. The device can achieve low analytical detections of certain chemicals due to long deployment times. The calculated concentrations of some target chemicals represent bioavailable concentrations for use in ecological risk assessments. Some limitations of the device are: surface water sampling for certain chemicals can be completed more effectively by other passive sampling technologies. Long deployments can result in buildup of biofilms and can interfere with extraction and analysis in the lab. Shorter deployments may not be advantageous to collecting a representative sample in certain media. Some key takeaways about the SPMD technology. The device can be used to sample a wide range of environmental media and collect a time-weighted concentration of target chemicals. The LDP membrane mimics fatty tissues of certain animals and is ideal for ecological investigations and risk assessments. The device is available in various sizes and configurations to meet a wide range of site-specific conditions and project goals. For more information on the semi-permeable membrane device and other passive sampling technologies, check out the ITRC Passive Sampling Update Web Guidance.